Imagine something wandering into our solar system, something that doesn't belong here. Not a comet born of our sun, not an asteroid from our belt, but a traveler from the deep silence between the stars. Astronomers called it Three-Eye Atlas, the third interstellar object we've ever seen. But the more they studied it, the more it seemed to whisper, "I'm not what you think I am." It didn't follow the rules. It moved like it remembered something. It reflected light, like it had a secret. And when scientists began connecting the dots, tracing its path, its light, its rhythm, a strange pattern began to emerge. A pattern that didn't just belong to the stars, but to time itself. Tonight, we'll drift together into that mystery, calmly, slowly, as if floating through a dream. The story of Three-Eye Atlas isn't just about space. It's about the strange feeling you get when you realize the universe might be alive and watching.
There's something haunting about the idea of a traveler that doesn't come from anywhere near us. A rock, a fragment, a messenger that has crossed millions of years just to pass by our tiny blue world. Three-Eye Atlas first appeared like a speck in a telescope's memory. Faint, soft, easy to overlook. Yet it wasn't random. It was moving too fast, too freely, almost as if it didn't care about the gravity that holds everything else captive. Astronomers often joke that the universe has a sense of humor, but this one felt different. This wasn't a joke, it was a whisper. Every orbit, every angle said, "I am from far away." The math confirmed it. Its speed exceeded what our sun could hold. That meant it didn't come from us. It came to us. From beyond the cradle of our light, you can almost imagine it, the darkness of interstellar space stretching endlessly, and this one small body wandering through it for millions of years, untouched by any system, any warmth, until it finds ours. What are the odds that something so small, so ancient, would choose our sky as its brief stage? Perhaps none of it was chance. Even the name interstellar feels too small for what it represents. Because when you think about it, something not born of our sun entered our home. It's like a stranger stepping into your living room from another galaxy, looking around quietly and leaving a trace of mystery in the air. Something about that changes how you see everything around you. And so began the story, not just of discovery, but of curiosity. A new visitor, a reminder that space is not a still painting, but a moving ocean. And in that ocean, something just brushed past us and kept going. As we follow that motion deeper, it started on a quiet night in early 2020. A survey telescope in Hawaii, the Atlas system, caught a small moving light on its wide-field scan. It looked like any other object at first. Just another data point, but its motion didn't match. Instead of orbiting our sun neatly, it sliced through space at a strange angle, like a visitor passing through, not staying. Scientists zoomed in on the readings. The coordinates shifted too quickly. The software flagged it, an unbound orbit. That term alone makes astronomers pause. It means the object isn't tied to the sun's gravity at all. Imagine tossing a pebble past a planet. It swings, it bends slightly, but keeps going. That was Three-Eye Atlas. Not a captive, but a passerby. They ran calculations again and again. Its velocity, its vector, its eccentricity, every detail told the same story. This thing wasn't local. It had entered our system at a breathtaking speed of nearly 60 kilometers per second. Nothing from the Kuiper Belt or Oort cloud could do that. That's when one of the astronomers murmured, "It's interstellar." And just like that, another door in the universe creaked open. You can feel the awe in that moment. Scientists staring at numbers, realizing they're watching something not from here. The world outside the dome was quiet, yet inside the telescope's eye, another galaxy's memory was passing by. It's almost poetic, isn't it? That something so ancient would announce itself not with noise, but with data. And as more observatories joined the chase, something stranger unfolded. The path of 3i Atlas began connecting with patterns from past visitors, just hinting, that there might be a design or at least a rhythm hidden in the chaos of space. And that question, what are we really seeing, began to ripple quietly through the halls of science. Every great mystery needs a name, and this one was given softly, 3i Atlas. 3i meant it was the third interstellar object ever confirmed after Oumuamua and Borisov, and Atlas honored the telescope that found it, the Asteroid Terrestrial Impact Last Alert System. But together those letters carried a quiet beauty. 3i Atlas, like the name of a star in a forgotten myth.
There's something poetic about calling it Atlas, a being who holds up the sky. Maybe that's what this object was doing in a way, holding up a mirror to our understanding of the cosmos. Astronomers love order. They name, they categorize, they measure. But with interstellar visitors, naming feels like an act of reverence. You're not labeling a rock, you're greeting a traveler. When they looked at the letters, some noticed something coincidental. Atlas means to bear or to carry. What if this object was carrying something? Not material, of course, but information. Stories from the void, fragments of collisions between stars, particles shaped by alien suns. That thought lingers in every scientist's mind. Space might not just be space, it might be a messenger system.
As the name spread across observatories, a quiet race began. Who could observe it before it faded? Because these visitors move fast, and once they're gone forever. Atlas was already dimming, its light barely visible to ground telescopes. But the name remained, a reminder that sometimes what you can't keep still leaves you changed, even now, if you close your eyes and whisper that name. 3i Atlas. It feels like you're calling something ancient back for a moment, just to listen, just to remember, and as we go deeper into its path, we start seeing the patterns it left behind. The letter I in astronomy doesn't just stand for interstellar, it stands for impossible, because for most of human history, astronomers assumed our solar system was an island, isolated, self-contained, comets, asteroids, dust, all born under the same sun, until 2017, when Oumuamua broke that illusion. Then Borisov confirmed it, and now 3i Atlas, the third visitor. The eye isn't just classification, it's a reminder that the walls around us were never real. Think of it. An object traveling across the galaxy through invisible rivers of dust and radiation, finally brushing past our star. The odds are astronomical. Yet here it was, proof that stars share debris, that the cosmos is constantly exchanging stories. It's humbling, isn't it, that what we once called ours is just a small pocket in an endless cosmic highway. The eye also marks a shift in how we see ourselves. It tells us we're not the center. We're part of a conversation between worlds, and every time one of these visitors arrives, it brings a whisper of that larger dialogue. Maybe that's why these discoveries feel emotional. They're not just about rocks. They're about belonging to something infinite. Astronomers now wonder how many such travelers pass unnoticed, how many glide through the darkness, unseen, unsung. If 3 have already come in just a few years, maybe they're always there, just quiet, just patient, waiting for our eyes to notice. That thought alone changes how you fall asleep under the stars. Because the I, that simple letter I, isn't just a mark in a catalogue, it's a signature, a cosmic signature that says this came from somewhere else. And once you've seen it, you can't help but feel like maybe, just maybe, somewhere else is watching back, When scientists traced 3I Atlas's orbit, the numbers didn't sit right. It entered from above the ecliptic plane. That's the flat disk where all planets orbit the Sun. Most comets and asteroids stick close to that disk, but 3I came from far above it, diving in from an angle that defied normal gravitational patterns. It was like a stone skipping across the top of a pond, not sinking in but gliding through. The calculations showed a hyperbolic trajectory, meaning it was moving too fast to ever be captured. The Sun's gravity bent its path slightly but couldn't hold it. That made it a true interstellar wanderer. But here's the part that sparked wonder. Its curve matched, almost eerily, the reverse arc of another interstellar object years prior. It's as if they were part of a mirrored design across time. That realization made scientists uneasy and excited at once. Could there be a hidden rhythm to these visitors? A pattern larger than coincidence? Every new dot on the map started to look like part of a bigger constellation, not in stars, but in motion. And maybe when you connect those motions, you find a picture we were never meant to ignore. Even in its exit, 3I Atlas behaved oddly. Its brightness fluctuated without explanation. Some thought it was breaking apart. Others thought it was reflecting sunlight in pulses, like a slow cosmic heartbeat. Either way, its path wasn't just geometry, but it was story. A silent message written across the dark. And as it vanished into the distance, the question lingered. What if these aren't just travelers, but time markers? Cosmic breadcrumbs left to remind us that space isn't empty. It's alive, patterned, and aware. Ahead in this video, we'll start connecting those dots. It's strange to imagine something entering our solar system without any announcement, no sound, no flash, no warning. 3I Atlas just appeared. It slipped in quietly from the northern sky, crossing boundaries that have stood untouched for billions of years. Unlike comets, which move in graceful ellipses around the Sun, this object came from nowhere measurable. It didn't follow a known corridor of space. It entered like a ghost through a locked door. Astronomers ran simulations, tracing its past path backward through time. Each model led to an impossible conclusion. 3I didn't come from any known star system nearby. It emerged from a direction with no clear parent star, no gravitational birthplace. That alone sent chills through researchers, because in the emptiness between stars, there's nothing to sling an object like that toward us. So what nudged it here? What unseen hand pushed it into motion? Some began wondering if interstellar space itself has currents, invisible streams of dust and energy that can carry objects the way tides move driftwood. If that's true, then 3I wasn't random. It was carried, perhaps for eons, by a cosmic flow we still can't detect. It makes you wonder what else might be drifting that same path. As it crossed Neptune's orbit, the Atlas survey began capturing faint glimpses, a weak reflection of sunlight bouncing off something icy, spinning, perhaps shedding faint dust. For a moment it became visible to our telescopes like a firefly gliding through fog. Then as suddenly as it appeared, it dimmed again, slipping back into darkness, but by then its coordinates were logged, and humanity had a new mystery to chase. When we look back at that moment now, it feels symbolic. How something older than memory could enter our tiny patch of space and remind us that we are never alone in the void. Something is always moving toward us, even if we can't see it yet. And as we follow this story deeper, we start realizing the sky remembers more than it shows. Every observatory has its quiet nights, hums of machines, the low chatter of researchers half awake. But when Atlas confirmed that the faint dot was moving too quickly, too freely, those rooms went silent. In astronomy, silence means realization. It means something impossible just happened. Within hours, observatories across the world, from Chile to Arizona, turned their mirrors toward the coordinates. And what they saw wasn't just motion, it was precision. The object wasn't tumbling like a normal rock. It was rotating steadily, rhythmically, almost as though it had balance, a kind of grace in its spin. That detail may sound small, but it changed everything. You could hear the disbelief in early radio exchanges between teams. It's not slowing. It's holding. It's consistent. For something so ancient and distant, that level of stability made scientists rethink what they were seeing. Was it natural? Or could something have shaped it long ago? Not built, perhaps, but guided. It's a dangerous word in science, or guided. Yet curiosity doesn't fear forbidden ideas. It only whispers them quietly when the data doesn't fit. Then came another surprise. Its brightness was inconsistent, sometimes too bright for its distance, other times dimmer than expected, as if the surface itself was changing or responding to light differently. It puzzled even the most logical minds, because behavior suggests awareness, or at least memory, and objects aren't supposed to remember. In the stillness of those nights, telescopes all over Earth pointed toward the same invisible traveler. It was as if humanity, for one fleeting moment, shared a single heartbeat with something not of this world. And maybe that's why astronomers couldn't look away. There's something deeply human about wanting to understand a visitor, even if you know it won't stay. When the data reached public archives, the debates began. Was 3I Atlas simply a fragment of ice and dust, or could it be something more complex, even organic in structure? No one was claiming life, but the possibility of intention entered the conversation quietly. The object's consistency, its steady spin, the way it seemed to reflect sunlight selectively, it all hinted at a pattern that didn't feel random. A few independent researchers noted something eerie. The timing of its appearance coincided with certain cosmic alignments, not in a mystical sense, but in mathematical ones. Patterns of resonance between planets, solar wind shifts, and background radiation peaks. It was as if 3I entered at the exact moment when our solar system's doors were open the widest. That's not proof, but it's strange enough to make even skeptics raise an eyebrow. Others proposed a biological hypothesis. Maybe not life as we know it, but molecular activity. Certain carbon signatures from its spectrum hinted at complex organic compounds. Nothing conclusive, but suggestive enough to fuel speculation. What if interstellar space isn't dead? What if, somewhere out there, fragments of ancient biochemistry drift for eons waiting to land where conditions are right? But here's what made it stranger. When 3I began to fade, its reflected light showed signs of polarization that didn't match normal dust behavior. It reflected in ways that seemed patterned, almost like a code written in brightness. Again, not evidence, just possibility. And that's all it takes to keep curiosity alive. Even now, years later, scientists still argue over what 3I truly was. Some say comet, some say rock, some say relic. But those who saw its first flicker know one thing. It felt alive in some quiet, undefinable way. Not breathing, but being, and sometimes that's all the universe needs to speak. Light doesn't lie, but it can whisper secrets in a language few understand. When researchers studied 3I Atlas through spectrographs, they expected the usual. Water ice, carbon compounds, traces of dust. But what they got was more complicated. The spectrum showed variations that changed faster than expected, as if the surface composition wasn't uniform. It was mixed. Part icy, part metallic, part unknown. That kind of mix shouldn't exist naturally in such proportions. It's like finding both volcanic ash and frozen methane in the same handful of dust. The readings suggested that 3I Atlas might have been through many environments, maybe ejected from one system, scarred by radiation in another, coated by new material in a third. It was, in essence, a traveler wearing 1,000 worlds on its surface. Even stranger, one data set showed small spikes in reflectivity that matched known laser wavelengths used in certain Earth experiments. Coincidence, of course, but haunting nonetheless. It raised the question, could natural processes mimic the precision of artificial light? Or are we seeing echoes of something we can't yet measure, like a communication written in physics instead of words? When the data was published, most scientists dismissed the anomalies as calibration noise, but a few quietly archived the results, unwilling to delete something that might mean more later. Science has a funny way of humbling us. What looks like an error today might be revelation tomorrow. 3I's light, though faint, carried a complexity that felt intentional, almost layered. To this day, its spectrum is stored in databases as unusual but inconclusive. Yet those who still study it often describe it differently. They call it haunting because sometimes light doesn't just illuminate, it remembers. And maybe what we call data is really the universe trying to tell its story. One flicker at a time. Every object in space spins, but 3I Atlas spun wrong. Its rotation wasn't random nor consistent with the forces acting upon it. Most comets tumble chaotically, slowed by solar winds or outgassing jets. But 3I rotated like a gyroscope in perfect balance, with periodic brightness shifts that suggested it was changing orientation deliberately, or at least unnaturally evenly. When computer models tried to predict its motion, they failed miserably. The light curve hinted at not one, but possibly two overlapping rotation periods, meaning it might have been precessing like a top, but too steadily for a simple icy fragment. Some described it as unnervingly elegant, as though the object had found its own rhythm against the rules of physics. That raised one of the strangest possibilities. Could it have internal structure, hollow pockets, density differences, or something designed to maintain spin? A natural explanation could fit, but even natural things rarely achieve that level of precision. Sometimes balance itself becomes suspicious when it's too perfect. Later, as it moved away, the spin seemed to slow slightly, not due to distance, but as if the object was responding to the sun's retreating light. That observation never made the headlines, but it stayed in the notes of those who were watching closely. Because response implies sensitivity. And sensitivity suggests something we still can't name. Whatever 3I Atlas was, it didn't behave like a mere rock. It danced. It turned with intention, with grace, as though space itself was conducting it. And perhaps that's what made astronomers fall silent watching it fade, because when something so small moves with such meaning, it makes you wonder what else out there might be moving us. The first thing scientists do when they find a visitor like this is rewind time. They trace its path backward through the stars, a mathematical unspooling of motion. But when they tried to find where 3I Atlas came from, the sky refused to cooperate. Every simulation, every line they drew, ended in uncertainty. The trail went cold among the constellations of Cassiopeia and Perseus, then vanished into darkness like it had stepped out of nothing. That's not how celestial mechanics are supposed to work. Every object has a parent system, a birthplace, a gravitational fingerprint. But 3I didn't. It came from interstellar nowhere, a direction with no recent supernova, no binary star breakup, no ejection pattern that made sense. That puzzled even the best dynamicists, because something must have launched it, and yet nothing fits. Some began suspecting that our catalogue of nearby stars might still be incomplete. Maybe 3I originated from a dim brown dwarf, one of those nearly invisible failed stars drifting quietly. Or perhaps it was older than any nearby system, a fossil from a forgotten cosmic era. That idea alone changed the tone of the conversation. This wasn't just another comet. It could be a piece of prehistory. And if it truly was that ancient, then it's seen things we can't imagine. The birth of new stars, the fading of old ones, the long quiet between galaxies. Every mark on its surface might be a scar from eons of travel. A timeline written not in ink, but in radiation and dust. And that's the kind of evidence no photograph can capture. Only silence can. What makes this haunting is the gap, the blank in the map where it came from. Usually science fills blanks with logic, but sometimes the universe leaves a space empty on purpose. And that space, that quiet unknown, becomes the most magnetic part of all. As weeks passed, astronomers kept trying to guess, if not from where, then from what kind of place. Some pointed toward the constellation Lyra, home to Vega, a bright star famous in ancient myths. Others said maybe it came from the direction of a small system named Kepler 160, where planets orbit a sun-like star. But every estimate carried uncertainty. 3i didn't belong to any known path. It was a loner in the truest sense. You can imagine the late-night debates. Scientists with coffee-stained hands arguing whether it came from a binary system or a solitary one. Binary systems are violent. They can sling out debris like slingshots. Solitary ones are calmer, slower. Yet 3i moved with an aggression that suggested it was expelled by something powerful, maybe even catastrophic. One researcher proposed it might have been born near a dying red giant, a star collapsing in slow motion, shedding layers into space. In that chaos, chunks of ice and metal could be hurled outward, forever free. If that were true, 3i might be carrying the ashes of a sun long dead, gliding across eternity with memories of fire in its core. Others whispered about a different origin, one outside the spiral arm of our galaxy. Because if you trace its motion just a little further, the trajectory aligns faintly with the intergalactic medium. That would make it one of the oldest interstellar fragments ever detected. Not from a star, but from between stars. That's almost poetic. A child of nowhere drifting home to no one. In the end, the debate never settled, but maybe that's the beauty of it. Some mysteries are meant to remain open, but because they give the night sky its depth. Without the unknown, the stars would feel flat. And 3i reminded us that even in the best mapped heavens, there's still room for wonder. When 3i Atlas's full trajectory was plotted, one eerie detail stood out. The object's path passed astonishingly close to Earth's orbital plane. Not colliding, not even dangerously near, but precise enough to make scientists pause. It wasn't random. Its line of travel skimmed just above the planetary disk, like a brushstroke drawn with intent. Some said coincidence, others weren't so sure. You see, in the grand chaos of space, true precision is rare. Comets from distant origins scatter in all directions, yet this one slipped into alignment almost elegantly. It felt guided. Of course, no scientist would ever say that outright, but the probability numbers spoke quietly. The odds of such alignment were vanishingly small. When the data reached NASA's Minor Planet Center, a few analysts even noted the uncanny timing. 3i crossed Earth's orbit near April, the exact period when our planet moves through a region historically rich with interplanetary debris. Some took it as pure math, others a message in timing. A cosmic rhythm that repeats, subtle yet deliberate. Even more intriguing, its relative velocity meant Earth's instruments could capture it better than usual, almost as if it offered itself for study. That may sound whimsical, but many astronomers admitted it felt as though the object wanted to be seen. Like it entered just when our technology was ready to notice. That kind of synchronicity makes even scientists pause mid-equation. Coincidence or cosmic choreography, who knows? But every generation of astronomers has one object that seems to acknowledge our gaze. For this century, that was 3D Atlas. Not dangerous, not demanding, just quietly aligning with us, as though to say, now you're ready to look closer. And we did. It started as a casual discovery. A young data scientist noticed that orbital parameters, when plotted logarithmically, mirrored certain ratios seen in previous interstellar visitors. At first, it looked like coincidence, but as more numbers fell into place, the pattern refused to disappear. The inclinations, perihelion distances, even the timing between arrivals, all shared proportional relationships. Not exact, but rhythmic, like notes in a song that plays across decades. The more they studied it, the more it resembled a repeating formula, not imposed, but embedded in nature itself. Could there be a gravitational resonance guiding these interstellar objects toward us in patterns we haven't yet understood? Some began calling it the interstellar sequence. 3 arrivals, each roughly 2 years apart, each carrying similar orbital energy ratios. That's not randomness. That's choreography. When these findings circulated quietly among astrophysics circles, it reignited an old debate. Does the universe operate on pure chaos or hidden order? Maybe everything, even wandering rocks, obeys a cosmic rhythm too vast for our brief lives to notice, like tides on a galactic shore, pulling travelers in at perfect intervals. It's easy to dismiss such talk as romantic, but math rarely lies, and sometimes math is more poetic than poetry, because these ratios, the ones no one expected to find, line up almost perfectly with orbital cycles of certain outer planets, meaning perhaps that our own solar system resonates with passing interstellar debris like a string responding to music far away. If that's true, then each visitor isn't random. It's a note in a cosmic melody, one we're only now beginning to hear, and when we finally learn to read it fully, who knows what message we'll find written between those numbers. Imagine drawing 3i Atlas's journey across the stars, not just in space but in motion. The line it makes is not a circle or a simple curve. It's a stretched hyperbola that slices through our solar system like a signature. When you tilt the coordinates and overlay them with other visitors, the paths begin to form something strange. An interlocking pattern, symmetrical and repeating, like petals of a vast invisible flower. That's when people began using the phrase, connect the dots. Because if you mark the points where interstellar visitors entered and exited, Tsintia Oumuamua, 2i Borisov, and now 3i Atlas, they trace an almost geometric figure across our sky. Not perfect, but meaningful. And meaning, even accidental, has gravity of its own. Some think this pattern is coincidence. Others believe it could reveal gravitational corridors, natural highways shaped by star systems' combined pull. These lanes may guide wandering objects between galaxies the same way rivers guide driftwood. If so, 3i wasn't random at all. It was following a cosmic current. But the strangest revelation came from mapping its spin axis against its trajectory. The two weren't aligned. They intersected at a curious angle, matching not the sun's rotation but Earth's. So that's not supposed to happen. It's almost like the object was responding to us. Observers described it as eerie, like being stared at by something that doesn't have eyes. And maybe that's what makes this story so quietly haunting, because the shape of its path isn't just geometry, it's invitation, a design drawn across centuries, asking us to notice. And as we go deeper ahead in this video, That design begins to reveal what might be the universe's most subtle form of communication. When scientists first measured 3I Atlas's speed, it looked ordinary for an interstellar object, fast but explainable. Then someone plotted the data differently. Instead of simple velocity, they looked at the small fluctuations in its speed as it passed through solar influence. That's when something odd appeared. A repeating numerical rhythm. Tiny deviations that weren't random, forming intervals like a pulse. Not mechanical, not artificial, but strangely musical. Every celestial body accelerates under the sun's gravity, but 3I's changes came in uniform bursts, as though something inside was redistributing its weight or energy. A natural process can explain this. Perhaps jets of sublimating ice or the cracking of frozen layers. Yet the pattern of these bursts aligned too cleanly, almost like beats in time. A cosmic metronome ticking silently through space. The more they analyzed it, the clearer it became. Its rhythm loosely matched the solar rotation rate. That means the sun itself might have been subtly influencing it through magnetic pressure or radiation resonance. But there's another possibility, that 3I somehow responded to that rhythm as though syncing to it, like a dancer catching the beat of the music around them. This synchronization wasn't perfect, just enough to raise eyebrows. It reminded scientists of pulsars where stellar remnants emit regular beams in perfect rhythm. But 3I wasn't emitting anything, it was reflecting, breathing light back in timed flickers, following an unseen pattern of motion. As if the object wasn't just moving through space, it was moving with it. To this day, researchers still argue whether those fluctuations were coincidence or signal. But one truth remains: velocity isn't just speed, it's conversation. And maybe 3I Atlas was having one with the universe, whispering in numbers we still don't know how to translate. Every rule in physics has its rebel, and 3I Atlas might have been one. You see, gravity is simple in its authority. Everything falls towards something. But as the sun's pull tugged on 3I, the object didn't respond the way it should have. Instead of curving smoothly around the star's path, it deviated, slightly, gracefully, like it knew exactly how much to resist. That tiny deviation changed everything. It wasn't enough to call supernatural, but enough to rewrite equations. The force required to cause such motion implied a non-gravitational push, perhaps gas escaping from beneath its crust. Yet telescopes detected none. No jets, no tails, nothing visible. It was being pushed by something unseen. That's when the non-gravitational acceleration debate began. Some whispered, "Oumuamua déjà vu." Others stared at the data in silence. Theories bloomed: solar radiation pressure, microdust outflow, even internal heating by cosmic rays. But none fit perfectly. The push was gentle, precise, as though someone, or something, was adjusting its course ever so slightly. That kind of perfection makes scientists uneasy. Nature doesn't usually draw straight lines with curved tools. And yet 3I's path continued to glide flawlessly. It bent just enough to keep balance between the sun and space. That balancing act, to this day, remains one of its strangest qualities. How could an object made of ice and rock defy the simplest rule in physics? That gravity always wins, maybe because it wasn't resisting gravity. Maybe it was working with it, like a surfer riding a wave instead of fighting it. That's the beauty of space. It never shouts its secrets. It hides them in precision. 3I didn't crash, didn't burn, didn't obey. It just moved differently, and that difference still echoes in equations scientists can't quite close. Newton's universe is predictable. Every action, equal reaction. Every force, an opposite balance. But 3I didn't play by those rules. The object's motion revealed small but consistent discrepancies in acceleration, like the cosmos itself was bending the edges of Newton's calm. It's unsettling when the universe starts coloring outside its lines. At first, astronomers thought it was error. Instruments, after all, aren't perfect. But cross-checks from multiple observatories confirmed the anomaly. 3i wasn't misbehaving by accident, it was following some principle we haven't yet written. It was obeying physics, just not ours, maybe an older version, or a deeper one. The pattern of its deviations suggested something elegant, almost artistic. Instead of random chaos, there was flow, smooth transitions between gravitational zones. Some physicists compared it to quantum tunneling on a cosmic scale, where particles skip boundaries without explanation. Could something similar happen with celestial bodies? Could space itself sometimes allow shortcuts invisible to our math? Others proposed a wilder idea, i.e., maybe 3i was composed of exotic material, a substance with properties we've never encountered, negative mass, dark matter integration, or superconducting ice that interacts differently with light and magnetism. That sounds fantastical, but so did gravity before Newton gave it a name. It's humbling, isn't it? How one small rock can challenge centuries of science. It reminds us that laws are only as strong as their last exception. And 3i Atlas, quiet and distant, might be the universe's way of saying, "You still don't know me yet." Ahead in this story, the mystery deepens into something even more daring, a possibility that intelligence once touched this traveler. No one wanted to say it out loud at first. The idea sounded too bold, too unscientific. But when natural explanations failed, whispers started spreading through conference corridors. What if 3i wasn't entirely natural? Not a ship, not a probe, but something engineered long ago, perhaps by forces that no longer exist. That thought alone sent a quiet thrill through the scientific world. The shape of 3i, inferred from its light curve, hinted at a long, thin structure, almost flat. Not a sphere like most comets, but more like a shard. That's rare. And the way it rotated evenly and stably defied random formation. It looked constructed, not recently, but eons ago, maybe by civilizations older than dust. This hypothesis wasn't fantasy. Theoretical physicists like Avi Loeb once suggested Oumuamua could be a fragment of alien technology, not functional but relic, a solar sail or piece of debris built to survive the dark. When those same arguments resurfaced for 3i, the community bristled, because once you open that door, science becomes philosophy. But the evidence didn't disappear. The reflectivity, the balance, the silence of gas, all strange. If it were artificial, it wouldn't mean aliens are coming. It would mean something even deeper, that intelligent life, somewhere, at some time, existed long enough to leave breadcrumbs between stars, and we just found one. Even if it's not true, the question itself changes us, because to ask if 3i might be designed is to admit we're not just looking into space, we're being looked back at. And that realization is enough to make anyone stare at the stars differently that night. It began as a half-joke whispered over coffee. What if it's a probe? No one meant it seriously. But as the data stacked up, the joke started sounding less funny. 3i Atlas had all the mystery markers: controlled light motion, unusual composition, stable spin, unpredictable dimming. Words like artifact and relic started slipping into conversations, not in press releases but behind closed doors. Of course, calling something a probe doesn't mean intelligence sent it to us. It could be ancient space debris, a fragment of long-lost exploration, like a bottle adrift in a cosmic ocean. Maybe whoever built it never saw us coming. Maybe it's been traveling longer than humanity has existed. That idea, both chilling and beautiful, gave new weight to every telescope image. Then came a strange observation. Radio telescopes detected an odd background fluctuation, not from 3i directly, but in the region it passed through. It wasn't a signal, just a pattern, almost like interference. Still, it made headlines in small corners of astrophysics forums. Probe theory rekindled. Some dismissed it, others archived it quietly for future reference. Science often hides its strangest files in footnotes. What made this even more haunting was timing. The night 3i reached perihelion, its closest point to the Sun, a minor geomagnetic ripple hit Earth. Completely natural, according to space weather data. But the coincidence lingered. Space doesn't usually align its timing so neatly, yet sometimes it does. If 3i was a probe, it wasn't one watching us. It was one passing by, carrying a memory we'll never decode. But maybe it didn't need to speak. Maybe just by showing up, by existing in our sky for a moment, it delivered its message. That we are not alone in this ocean and we're simply the next travelers to notice the tide. Before 3i Atlas, there was another visitor, the one that started it all. In 2017, Oumuamua drifted through our solar system like a silent spark, the first known interstellar object ever detected. It moved fast, reflected light oddly, and accelerated mysteriously. Much like 3i, scientists were stunned. They thought Oumuamua was a comet, then an asteroid, then something else entirely, until they gave up and simply called it unclassified. Years later, when 3i appeared, astronomers couldn't help but remember that first visitor. The similarities were impossible to ignore: the speed, the spin, the subtle defiance of gravity. It felt as if space was sending us sequels to a story we hadn't yet understood. This can't be coincidence, one researcher said. It's like the universe is repeating itself on purpose. And maybe it was. Oumuamua's shape had been described as a thin shard, cigar-like, maybe pancake flat. Impossible to define clearly. 3i's shape, too, seemed stretched, refined by eons of travel. The two weren't twins, but cousins. Fragments of the same cosmic event, perhaps? Or parts of an ancient system that broke apart long ago. The idea stirred both wonder and fear. Even their paths seemed related. Two distinct arcs entering the solar system from opposite sides, like paired messengers meeting across time. The more you traced the lines, the more it looked like a pattern forming, a rhythm repeating itself not in sound, but in movement. History doesn't just happen on Earth, one astrophysicist murmured. It happens in the sky, too. And so, when 3i Atlas arrived, it wasn't just new data. It was déjà vu. A haunting continuation of something that began years ago. A reminder that in the theatre of stars, stories rarely end. They just wait for the next act to unfold. If you placed 3i Atlas beside Oumuamua and 2i Borisov, it would be like comparing three mysterious letters from unknown senders. Each carried different handwriting, different tone, but all seemed addressed to the same recipient, us. And just like old letters, their content was fragmentary, incomplete, yet emotionally charged with meaning we can't yet translate. Oumuamua came first, dry, fast and silent. Borisov followed, wet, volatile, leaving a comet-like tail. Then came 3i Atlas, a mixture of both, as if combining qualities of the previous two. It was like evolution through objects. One could almost imagine the universe conducting an experiment, adjusting each iteration, refining the message until we finally noticed the pattern. Scientists analyzed everything: composition, orbit, spin rate, temperature decay. And one strange fact stood out. The intervals between their arrivals were almost evenly spaced in Earth years. That doesn't sound cosmic, it sounds timed. Of course, coincidence is possible, but the timing still whispers of rhythm. Something about it feels deliberate, even if it's only the illusion of order in chaos. Comparing the three also revealed another layer. Their trajectories form angles that, when plotted on a celestial grid, trace nearly symmetrical paths across the ecliptic. Random, maybe? But in the quiet of a telescope room, randomness starts to sound like code. And when three visitors arrive in sequence from different corners of infinity, you start to feel like someone, somewhere, is sending postcards across time. And maybe that's what these visitors are. Fragments of a single phenomenon stretched across centuries, reminding us that discovery often happens not in isolation, but in chapters. 3i wasn't the first, and it certainly won't be the last. When astronomers noticed the regular intervals between these interstellar arrivals, it sparked a quiet kind of wonder and a bit of discomfort. You see, in nature, randomness rules, objects wander, yet the timing between Oumuamua, Borisov, and 3i followed a pattern, roughly 2-year gaps like clockwork from the galactic background. And timing always tells a story. Some suggested it was coincidence, a statistical fluke, but the odds of 3 interstellar objects passing through the same small patch of space within a human decade, astronomically low. So the question became, what's organizing them? Could there be gravitational highways linking star systems, pathways through which debris travels more easily? Or something even stranger, like a repeating cycle written into the Milky Way's own motion? Others took the poetic route. Maybe the universe releases these wanderers periodically, like breaths in a slow cosmic exhale. A rhythm too vast for us to perceive consciously, yet steady enough for our instruments to record. Space doesn't move randomly, it flows. And perhaps these arrivals are ripples in that flow, marking the pulse of the galaxy itself. One small team even theorized that passing through dense molecular clouds could slingshot debris outward every few million years, sending out fragments in waves. Each wave would scatter, but a few pieces, or lashing like 1i, 2i, and 3i, would find their way to us, perfectly spaced in time. A cosmic pattern born of chaos, but patterned nonetheless. It's humbling to think we're only now catching the rhythm of something ancient. And so the arrivals might not be random at all, they might be the quiet ticking of a universal clock. One we've only just learned to hear. If that's true, 3i wasn't an accident. It was an appointment kept precisely on time. Every mystery finds its prophet, and for this one, that prophet was Dr. Avi Loeb of Harvard. Years before 3i appeared, he'd already warned the scientific world, interstellar visitors will come again, and when they do, we must look deeper. Many dismissed his theories, especially his suggestion that Oumuamua could be technological debris, a fragment of alien design, not a comet. Yet when 3i arrived, his forgotten papers resurfaced like messages from the past. Loeb's equations spoke of radiation pressure, surface area, and acceleration ratios that could mimic the behavior of lightweight, reflective structures, things like solar sails. He didn't claim 3i was a spacecraft, but he suggested something deeper, that intelligent life might naturally create byproducts that wander through space long after civilizations fade. The universe, he said, may be full of orphaned technology. When 3i followed almost the same script as Oumuamua, those equations gained new life. Suddenly scientists revisited old data through Loeb's lens, and the numbers began whispering again. Could both objects belong to the same lineage, descendants of a civilization that once sent their creations into the dark? The thought lingered, uncomfortable and beautiful at once. Of course, the mainstream rejected the artifact idea, at least publicly. But in small groups, late at night, researchers still discussed it. Because Loeb's math didn't lie, it worked. And the resemblance between these visitors was undeniable. Coincidence? Or the echo of a theory too daring to die? Sometimes ideas arrive before their time, just like the objects they describe. And maybe Dr. Loeb's equations aren't just calculations. Maybe they're invitations to look up, question deeper, and accept that sometimes the truth feels like fiction until the sky proves it real. This is where things start feeling almost mythical. When a few astronomers plotted the entry points of all known interstellar objects on a wide celestial chart, something astonishing appeared. Their trajectories, when extended outward, aligned roughly with several ancient star pathways recorded by early civilizations. Lines once drawn by Sumerians, Egyptians, and Mayans, routes they claimed were paths of the gods. At first, everyone dismissed it as pareidolia, the human mind's tendency to find patterns where none exist. But the alignment was oddly consistent. The lines drawn thousands of years ago matched the direction of modern discoveries, not perfectly, but eerily close. It's as if ancient sky watchers somehow sensed the same invisible geometry modern astronomers are just beginning to see. Historians began revisiting ancient records, scrolls, carvings, temple ceilings. Many described traveling stars that appeared briefly and vanished. Could those have been interstellar visitors too? The timelines don't align neatly, but myths rarely do. What matters is the echo, the possibility that human memory holds fragments of cosmic events we've long forgotten. It's humbling, really, to think our ancestors might have looked at these same visitors, given them divine names, and etched their paths into stone. We call them Three-Eye Atlas. They called them messengers. Two different languages, one shared awe. And maybe that awe, that instinct to trace the unknown, is the real connection across time. When you overlay those ancient maps with modern ones, something quiet happens inside you. You realize that humanity has always been connecting the dots, not just between stars, but between centuries. And maybe, just maybe, Three-Eye Atlas isn't just another cosmic visitor. Maybe it's a reminder that we've been watching and being watched for much longer than we think. When the orbital map of Three-Eye Atlas was projected against the sky at different times, one subtle alignment emerged. Its entry and exit points passed close to the same celestial corridor, traced by ancient star priests thousands of years ago. In Sumerian and Egyptian records, that corridor is described as the River of the Heavens. Astronomers today call it a band of faint stars between Perseus and Cassiopeia. For Three-Eye to travel along this line is not impossible, but it's striking enough to catch attention. Some researchers suggested the alignment is coincidence, but even skeptics admitted it's rare for interstellar objects to coincide with such old sky marks. The ancients didn't have telescopes, yet somehow they drew maps that echo paths we're just beginning to plot. That echo gives a strange sense of continuity, as though our sky memory is older than our written history. Others speculated about preferred lanes in the galaxy, gravitational seams that naturally funnel debris. If those seams intersect with constellations we've long mythologized, then the ancients may have unknowingly mapped invisible highways of space. Not magic, not prophecy, just careful watching over centuries. It's almost poetic to imagine Three-Eye gliding through a corridor marked by forgotten astronomers thousands of years before our telescopes. Two civilizations separated by millennia, noticing the same silent traveler's road. One carves it into stone, the other into data logs, both in their own way, connecting the dots, and that's what makes Three-Eye feel like more than a rock. It's a bridge between stars, between times, between ways of seeing. And as we move further, the question deepens. What else have we mapped without realizing? If interstellar visitors pass every few thousand years, could ancient peoples have seen them too? The records suggest they did. Sumerian tablets speak of wandering sparks that moved too quickly to be planets. Mayan codices describe icy messengers that glowed briefly and vanished. Even Aboriginal sky stories tell of stones from the infinite dark that appear without warning. All of them may be echoes of rare, bright travelers like 3i. Of course, myths are not data. They're stories shaped and reshaped across generations. But myths often begin with something real: a comet, a meteor shower, an interstellar visitor. The details drift, but the memory lingers. And when you line up those old accounts with modern astronomy, the coincidences are eerie enough to make you lean closer to the page. Imagine a farmer 4,000 years ago looking up at a strange moving light. He doesn't have instruments or math. He only has his eyes and awe. He tells his children, they tell theirs. Eventually, the story becomes divine. A messenger, a sign. Not because it was magic, but because it was rare. Rarity always becomes sacred. That thought changes how you look at 3i. We call it data. They called it gods. But both words mean the same thing at their core. Something bigger than us, something we can't control. In a way, every interstellar visitor is a shared experience across all time. We all stop, look up, and wonder. And perhaps the most haunting part, they might have watched the same visitors we're only now naming. If so, 3i isn't just our discovery, it's our reunion. In the myths of the Dogon people of Mali, a wandering starseed arrives from beyond the visible sky. In Norse sagas, a sky shard crosses the world tree unnoticed by gods. In Chinese scrolls, guest stars are recorded with dates and positions eerily precise by modern standards. Across cultures, a theme repeats: travelers from beyond, moving through the heavens, leaving nothing but wonder behind. When researchers began comparing these myths to 3i, patterns surfaced. Descriptions of objects that appear without tails, accelerate oddly, or vanish as if swallowed by dark. Those are not typical comets. They're rare, irregular. They sound a lot like interstellar visitors. It's as if humanity's oldest stories are faint fingerprints of cosmic events we've forgotten to measure. Even more curious, many myths speak of such visitors as messengers rather than warnings. They're not omens of doom, they're carriers of knowledge, or time, or change. That's exactly how 3i feels today, not threatening, but teaching. Not crashing into our world, but brushing by it, asking us to notice. The parallel is almost comforting. This isn't to say myths prove anything, but myths guide curiosity. They're like footnotes left by ancestors who couldn't write equations but could still see the sky. And if those footnotes point to real cosmic rhythms, then maybe, just maybe, our oldest stories are maps waiting to be decoded. It's humbling to think we're living inside the same narrative arc as our ancestors, just with better instruments. The visitor changes names. The story stays the same. Ancient cultures didn't just see stars, they connected them. They drew animals, gods, and heroes across the sky. They didn't do this at random. Constellations were calendars, compasses, and quiet archives of rare celestial events. If something unusual appeared, they'd weave it into their star lines. That's how knowledge traveled, not in books, but in pictures overhead. Now, as astronomers plot 3i Atlas's path, they're essentially doing the same thing. They're drawing lines between data points, finding shapes in motion. The difference is technology, not instinct. Because connecting dots is how the human mind finds meaning. It's how we build stories. It's how we survive uncertainty. Some of the constellations 3i passed through, Perseus, Cassiopeia, are among the oldest named. Why those? Because those were the regions where bright guest stars tended to appear. Novas, comets, wanderers. If interstellar visitors follow gravitational seams, then ancient skywatchers might have mapped those seams unknowingly, encoding them into mythic shapes. Our modern orbital maps may just be confirming what they already sensed. The image of a sky god drawing lines between stars feels almost like a metaphor for what we're doing with 3i. We're trying to draw its portrait from scattered dots of data, and maybe the portrait we end up with isn't of a rock at all, but of the galaxy's own hand guiding its driftward to us. And when you realize that, the night sky stops feeling empty. It starts feeling like a message board written across eternity. For all the connections, one thing about 3i still doesn't fit. When you overlay the entry points of the 3 interstellar visitors, there's a blank spot, a missing fourth point that would complete the geometric pattern their paths seem to form. It's as if the sky is drawing a shape but hasn't finished. Some astronomers half-jokingly call it the phantom dot. Others wonder if it's not missing at all, just unseen. This blank fuels speculation. If there's a fourth visitor following the same rhythm, it might already be on its way, perhaps dimmer, slower, or coming from a direction we're not yet scanning. The idea that something else is out there right now, gliding silently toward our solar system, is both thrilling and unsettling. Patterns invite expectation. Once you see them, you start waiting for the next note in the melody. That's what 3i has done to astronomy. It's made us listen differently. Not just for random rocks, but for rhythms, for echoes, for continuations. And waiting can be just as profound as discovery. Some even theorize that the missing dot isn't physical, but temporal. Maybe the fourth visitor came centuries ago, recorded as a sky sign in a forgotten text. If so, the pattern isn't incomplete. We're just missing the memory. That possibility makes you feel small and infinite at once. And so, as we drift deeper into 3i's story, we're left with a question older than science. Are we uncovering a cosmic coincidence, or reading the first lines of a message too vast to fit in one lifetime? Ahead in this video, the next chapters will start connecting those missing pieces into something larger than a pattern, something like a voice hidden in the dark sky. Once 3i Atlas was confirmed as interstellar, NASA and other agencies began tracking it more closely. Not with flashy press conferences, but with quiet, continuous observation logs, the kind that don't make headlines but end up shaping future missions. These logs revealed not just coordinates and brightness, but subtle changes, micro-variations in trajectory, flickers in reflectivity, and faint spectral oddities. It was like reading the travel diary of an object older than civilization. Most of these logs are public, but buried, spreadsheets of numbers and timestamps. Yet hidden in that monotony are patterns that hint at something more. Small deviations that match magnetic field fluctuations. Brightness pulses coinciding with solar wind gusts. Not proof of intelligence, but evidence of sensitivity. And sensitivity itself feels like a quiet form of awareness. Some insiders say the real treasure isn't the data itself, but how it might guide future missions. If we ever want to intercept an interstellar object, we'll need these logs to predict their arrival and behavior. 3i gave us a rehearsal, a rare chance to test our readiness for visitors from the dark. It's telling that NASA didn't hype 3i like Oumuamua, perhaps because hype distorts focus. Instead, they watched in silence, collecting the kind of information that ages well. In that sense, 3i was both mystery and mirror, showing us not only its path, but how we choose to study what we don't yet understand. And sometimes silence is the loudest response. The object drifted on, the logs continued, and somewhere in that quiet record a story still waits to be fully read. Brightness in space is usually predictable. Sunlight hits a surface. Light reflects. But 3i Atlas had moments of unpredictability. In March of its closest approach, observers noticed a sudden increase in brightness, not dramatic, but enough to stand out in the data. It was as if the object had briefly flared, then dimmed again. That's not normal for a rock gliding through cold space. One explanation was fragmentation. Maybe a piece broke off, exposing fresh ice to sunlight. Another was rotation. Perhaps a reflective face turned toward Earth, but the timing of the flare coincided with a solar wind spike measured by satellites. Was it coincidence, or was 3i reacting to its environment in a way we didn't expect? Even stranger, the flare didn't follow a simple curve. It flickered in a pattern, 3 pulses of brightness over 2 hours, then steady again. Astronomers rarely use the word pulse for comets, but here it fit. It was almost like a heartbeat. Slow, faint, deliberate. That image stuck in the minds of those who saw it. Afterward, the object returned to normal brightness. The event was logged, archived, and labeled unusual, but inconclusive. But for a few nights, a handful of scientists felt they were witnessing something more than light physics. They were watching a story flicker in real time, one whose meaning might not be clear for decades. Moments like that are why astronomers keep looking up. Not because they expect answers, but because sometimes even a flicker can change the way you see the sky forever. A month after the brightness flare, a subtler event occurred. The object's trajectory showed a small temporary pause. Not a stop, of course, but a slight reduction in its acceleration rate, followed by a gentle increase again. Space doesn't usually allow such pauses. Once you're moving, you keep moving. Yet here was 3i behaving as if it were taking a breath before continuing on. Models tried to explain it. Some said it was a hidden outgassing event, counteracting the sun's pull. Others said it was an observational artifact, a blip in the data. But the timing was too neat. The pause occurred at a point in its orbit that lined up with a subtle resonance between Jupiter's gravity and the sun's, like a surfer catching a wave crest before sliding down again. If true, this would mean 3i navigated gravitational influences with an elegance no comet usually shows, not fighting forces but flowing with them. It's a small thing, a pause of fractions of a kilometer per second. But in cosmic terms, it's like watching a stone in midair suddenly change its fall without a hand touching it. This is why some scientists speak of 3i in tones usually reserved for art. It's not that it's alive or engineered, it's that its motion feels composed. And when motion feels composed, it makes you wonder who or what wrote the sheet music, or if the music writes itself and we're only now learning to hear it. That pause may be forgotten in mainstream reports, but in private notes it's still circled in red, because in science, anomalies are the compass pointing toward the next discovery. By the time 3i was leaving the inner solar system, teams around the world had built models to describe it, dozens of equations, hundreds of simulations, yet none of them could fit every data point. Fix one anomaly, another popped up. Adjust albedo, the acceleration broke. Adjust mass, the brightness curve failed. It was like trying to solve a puzzle where the pieces kept shifting. This isn't unusual for early observations. Data is messy, but what made 3i stand out was how persistent the mismatch remained, even as more data came in. Usually, better measurements iron out anomalies. Here, they sharpened them. The closer we looked, the stranger it got. That's rare. One astrophysicist likened it to an optical illusion. You think you see the whole picture, but each adjustment reveals another hidden layer. In one model, 3i behaved like a loose comet. In another, like a dense shard. In a third, like a thin sail responding to radiation pressure. None captured it fully. It was as though 3i refused to be categorized. This defiance of classification changed the conversation. Instead of asking, "What is it?" scientists began asking, "Why does it defy?" And that's a subtle but profound shift, because sometimes the answer isn't in the label but in the refusal to be labeled. In that refusal, you glimpse the edge of a deeper truth, and that nature's vocabulary is still bigger than ours. To this day, the 3I problem lives in papers and conference slides as a reminder. The universe isn't obligated to be simple just because we want it to be. And maybe that's its most beautiful quality. In the cold void of interstellar space, sunlight fades quickly. Most objects grow dim, their icy surfaces dull under cosmic dust. But 3I Atlas surprised observers by maintaining a soft glow even as it retreated. Not bright, but steady, like an ember that refuses to go out. Its brightness curve didn't follow the usual decay. It glowed when, by all accounts, it shouldn't. Spectral data hinted at an unusual mix of reflective compounds. Maybe metallic flakes embedded in ice, maybe crystalline structures formed under alien pressures. Such surfaces could act like mirrors, catching sunlight more efficiently. But there was also a strange thermal reading. It seemed slightly warmer than expected for its distance. Not hot, just less cold. That small discrepancy caught everyone's eye. Some speculated that cosmic rays had altered its surface chemistry, making it sparkle longer. Others proposed a more radical idea: internal heat from slow radioactive decay or trapped energy. But the truth is, no one knows. The glow simply lingered, like a candle flickering in a vast, dark cathedral of space. What's striking is how emotional that glow feels when you see it in the data. Numbers on a screen shouldn't stir anything. Yet here was an object, older than Earth itself, glowing faintly as it drifted away, like a farewell we could almost feel. One astronomer described it as watching a lighthouse fade on the horizon. And maybe that's what 3I was, a lighthouse not for us, but from somewhere far away, not to warn, but to remind there are other coasts in this ocean, even if we can't yet see them. Ahead in this video, we'll follow that fading light into deeper patterns, the magnetic whispers, the hidden symmetry, and the possibility that 3I isn't alone. ChatGPT can make mistakes. Check important info, see cookie preferences.